Hi, I'm Manfred from the bada team of Samsung Mobile Innovator. In this video, I'd like to talk to you about how to create attractive user interfaces on the bada platform. In particular, I will show you how to use the touch interface supported by bada. This video is one of the essential bada series, so make sure you check out our blog at developer.bada.com or watch our YouTube videos. Bada is not just a software platform for mobile handsets, it's the whole ecosystem required to bring your innovations to the market. This ecosystem is brought to you by Samsung and provides all the tools you need. In order to facilitate development, bada is shipped with a full-featured IDE that is based on Eclipse. Here, I refer to the version 1.0 of the SDK, which is the most current during recording of this video. In today's video, I will look at the functions required to build touch-enabled user interfaces with bada. I will start with an overview of the latest developments in user experience and user interface design. After that, I will run through some of the necessary namespaces and essential classes offered by our libraries. Then, we will get our hands dirty on two coding examples. The first example will demonstrate drawing on the screen with your fingers and covers single touch events. The second example builds on this and will show you how to support multipoint touch features. And finally, I will demonstrate the compiled example using the bada simulator, which is great for testing bada applications. User interface design and user experience are critical to the success of your application and are hot topics in mobile application development. The user's interaction with mobile devices, applications, and services is unique. During the last couple of years, we've been learning about the significant differences in the way that users interact with desktop versus mobile software. We've moved from the Windows icon mouse pointer era to the new multipoint touch, physics, gestures paradigm. Also, there are various contextual factors to consider, which can be tricky. Mobile users pay the greater part of their attention to their current activity, such as walking and orienting in a range of potentially unfamiliar environments. So it helps if they can think less about how to interact with a mobile device. Luckily, in recent times, better user interaction technologies have been developed and can now be exploited to create a simple and intuitive mobile user experience. The bada platform supports assorted means of user input and output, and a variety of different sensors can be used to extend the UI of mobile applications, such as tilt, accelerometer, proximity, light, temperature, motion, snap, shake, or tap. A further factor that influences the user experience with the mobile app is the screen technology. The first bada-powered device, the Samsung Wave, is equipped with a Super AMOLED display which has its origin in televisual technology. This display technology distinguishes itself through 20% brighter screen, deeper colors, better contrast, 20% less energy consumption, and 80% less sunlight reflection as compared to older mobile displays. For a number of years, we've all been fascinated by a very prominent type of user input mechanism, the touch screen interface. Of course, you can make use of a variety of different touch events with the bada SDK. So let's take a look at a couple of code examples to illustrate them. In this video, I want to show you coding examples about how to enable single and multipoint touch input within a bada form UI control. And I will describe the code for receiving and handling touch events. The touchscreen input is handled by the application and will be used to draw lines on a graphics canvas. A line will be drawn following the motion of a user's touch input, and a double tap is used to clear the canvas. In this example, we principally make use of two namespaces, OSP UI and OSP Graphics. From the UI namespace, the classes that are most useful are Touch, Touch Info, and the interface iTouch Event Listener. The Touch class supports multipoint touch and provides information such as the position on the screen or the number of touches. Its method getTouchInfoListN returns a list of touch info objects which hold information about touch events such as touch pressed or touch released. From the graphics namespace, we will focus on the Canvas class. A canvas is a rectangular area where the graphics rendering takes place. It contains settings that are used in the drawing operations such as line style, line width, font, background, and foreground color. There are two types of canvas. The normal canvas is explicitly created using the canvas construct method. It is unknown to the window manager, so it can override other windows or get overwritten. The window canvas can be retrieved from UI control instances with the getCanvasN method. It is managed by the system's window manager, so changes in the window get reflected properly. As I mentioned earlier, bada supports single and multi-point touch features. To show both, I have prepared two bada software projects, Single Point Demo and Multipoint Demo. Let's have a closer look at the Single Point Demo. The relevant class is Single Point Form. The Single Point Form class inherits from the base class Form. In order for it to handle events from the touchscreen, the Event Listener interface OSP UI iTouch Event Listener has to be implemented, and the following methods need to be defined. OnTouch double pressed, OnTouch focus in, OnTouch focus out, OnTouch long pressed, OnTouch moved, OnTouch pressed, and OnTouch released. The creation of the canvas and the registration of the touch event listener are performed in the onInitializing method. We create and construct a normal graphics canvas and set its size and position based on the available area. We set the background color of the form to white. We set the background color of the drawing canvas to white and its foreground color to blue. We set the line width for the drawing canvas to 5 pixels. Next, we clear the drawing canvas and create the point object to store the start position for the drawing. Now we register the iTouch event listener implemented by our Single Point Form class by invoking addTouchEventListener on it. To create a custom drawing on the graphics canvas, we must implement the onDraw method. And within the onDraw method, the getCanvasN method is used to retrieve a pointer to the canvas that our form is using. Otherwise, the default draw method of the form would override the custom drawing of our normal canvas. Remember that the trailing end notation of the methods mean that the object ownership changes. We have to deal with what comes back from the getCanvasN method. In this case, we have to explicitly delete the pWindowCanvas object. In this code example, the onDraw method copies the contents of the drawing canvas to the window canvas because the display is actually updated automatically when the show method is called following the onDraw callback. In order to handle the touch events when they occur, we insert our logic into the corresponding methods. In this example, we only use onTouch pressed, onTouch moved, and onTouch double pressed. Each method is passed information about the source of the event, the current touch position, the start position, and the status of the event. The touch pressed event occurs when the user touches the screen. This event is handled by the onTouch pressed method, which is used to set the start position to the position touched by the user, which we store in the point object. This touch start position is used in the onTouch moved method for line drawing. The touch moved event occurs when the user has moved the fingers across the screen and registered a touch event. We use the onTouch moved method to draw a line from the stored touch start position to the current position. After the line is drawn, the touch start position is set to the current position. The touch double pressed event occurs when the user double taps on the screen. This event is handled by the onTouch double pressed method. We use it to clear the graphics canvas. Now we are finished with the code. We can compile it and run it in the simulator or on a real device. The simulator behaves as expected. By touching and moving on the screen, we can draw lines. And by simulating a double tap, we clear the screen. The second example is very similar to our first. The major difference being that we will add support for multi-point touch features to draw several lines simultaneously. In the first example, we stored a single point in a member variable of type point. But this time, we want the second example to handle multiple touch points. So now we introduce a member variable of type iList that holds pointers to all the touch points of our multi-point example. In addition to the initialization of the drawing code and the registration of the touch event listener, the onInitializing method now needs to be modified. This will enable multipoint touch events for our new form, which in this bada project we call Multipoint form. This is done by creating an instance of a touch object and enabling multipoint touch using the setMultipointEnabled method. The touch object provides a method getTouchInfoListN, which returns a list of multipoint touch events, each represented by a touchInfo object. Here we update the onTouchPressed method to store the list of touch positions into the iList member variable. Now, the onTouchMoved method needs to be adapted for multipoint touch. Originally, we drew a line from the stored touch start position to the current position. Now, we carry out the same line drawing for the multiple touch points that we have stored in the list. In the onTouchMoved method, we perform the following steps to draw these multiple lines. Firstly, retrieve the list of touchInfo objects for the current multipoint touch events. Then, ensure that the pointers for the lists of previous and current touchInfo objects are valid and have the same number of items in them. If they do, iterate through to the end of the list, and for each item we do the following. Get the touchInfo object for the previous touch event and the current touch event. Draw a line from the previous touch position to the current touch position, retrieving the position information for each point from the touchInfo objects. Then set the previous touchInfo list item to the current item. Then delete the list containing the current multipoint touchInfo objects and draw the multipoint form as before. Now that our code is modified for multipoint touch, we can build and run it via the simulator or on a real device. Multipoint touch events can be tested in the simulator by holding down the control key on your PC keyboard and clicking the mouse at various points on the screen. A gray circle will be displayed on the simulator to indicate the touch points. To generate multiple touch pressed events, release the control key after clicking the mouse at the required points. To generate multiple touch moved events, keep the control key pressed and drag each of the gray circles to the required position, and then release the control key. In this video, we showed you one way to create an attractive user experience with bada. We made use of the touchscreen interface, where I introduced you to bada's UI and graphics namespaces, and some of the related classes and interfaces. The first code example covered basic functionality and event handling with respect to single-touch events. And the second code example showed you how to support multipoint touch events. Both examples were tested in a simulator, which can simulate single and multipoint touches. We hope you enjoy bringing your great app ideas to life on the bada platform. Extensive documentation is provided in the SDK, and there will be further technical walkthroughs available. So please keep checking our website, developer.bada.com, for more crunchy bait to finally dive into bada. Thank you for watching.